Yesterday, I recorded the 7th period lecture because I had forgotten to do it first period. So maybe you saw that show up on your Google Classroom. Those are just resources. You can ignore them if you don't want to see them. They are not something that you have to open up and watch, but they are there now so that at least later on in the day, once the computer has processed everything, then you can get access to it again. And you can fast forward and you can skip around. Um, and it's not just a one-shot deal. I do encourage you, as class goes on, be sure you have your pencil and some paper. It doesn't have to be a clipboard, but have some place that you can write and draw things. Because in chemistry, drawing, especially now that we're getting into molecules and how they behave, is going to be very important. Before we could sort of just do it with QWERTY keyboard, with the numbers and that sort of thing. It's going to be more difficult to do that, and so to communicate with each other, we're going to need to use a surface that has more of a drawing capability. So I just want to encourage you to have those resources nearby, or else you might have things slip through. And I want you to be learning things. Let's see here. Not forgetting things. So let's see here. Speaking of which, I'm going to open up a Jamboard here. Yes, somebody have a question? Yes, Layla?
Oh, no.
Okay. Let me just pull this over here to the projector. And that's okay. Back to your drive. Okay. All right. Back to the Zoom meeting and share screen. And there we go, the Jamboard. Okay, so you see there a very blank Jamboard, and as I am going to do some drawing here, I'm going to be using my mouse, and hopefully you have a stylus that works on your computer. If it doesn't, if you don't have one, then you don't need to use the touch screen. You can still just use the mouse pad, or you can get an external mouse. They're not that expensive. But at some point you do need to be able to do drawings. Okay, so I'm going to select the pen here, and I'll stick with pen, and I'll even stick with black, that's the default. And then, yeah, that's good. All right, I'm going to also set a background because kind of white is kind of boring. I'm going to go with the one with the dots. Okay, and that just allows me to kind of make distances consistent. So I put a dot here. I'm going to do a little squiggle just to make it a little bit more visible. Okay, and that is maybe like the nucleus of something. And then when I go down here to the shapes, I can get a circle. And although you know that only the S electrons truly make a spherical shape for the electron clouds, and the P's are more like peanuts. When you average out the P, morning, Gavin. When you average out the P, and remember that the atom is constantly rotating, then it to all intents and purposes, is like a sphere. And so if we draw it like that, it's kind of an oval. But if I just hit delete, if I hit shift while drawing it, oops, I gotta go back down here. Shift, oh, it doesn't work on this one. Oh man. Let's try alt. Nope, that does nothing either. I thought I had something cool to show you. Nope, nothing cool. All right. Well, in a different painting program that I was using, if you held shift, then it would make it a perfect circle. But In any case, if I were to make this truly to scale, it wouldn't even fit on this Jamboard with this nucleus like that. So I'm not going to be worried too much about ever drawing any nuclei. And in fact, I'm going to go ahead and erase the nucleus that I have drawn there, just to start with a clean slate. So when we were doing earlier chapters like 5, 6, 7, we were very much interested in the nucleus and the particular layers of electrons. But that's so that we could get to the point where we're dealing with the valence electrons. The valence electrons are the ones that are going to do anything in chemistry. Everything below that, at least for the main group elements, all of those electrons below the valence, they're just a solid, well, not solid, but you know, they are kind of unchangeable. They're the noble gas that's at the heart, kind of like the Russian dolls analogy I made. They're at the heart of the atom, and they don't really enter or leave. Now with the transition metals, once in a while something happens with the d electron, 1 or 2 d electrons, particularly if something that's very electronegative like fluorine or oxygen gets involved. Now fluorine is very strong, but it's kind of rare. But oxygen, even though it's slightly weaker than fluorine for electronegativity, is much more common. And so most of the time you see anything weird happening with the transition metals, the ones that on the in the Pearson book are labeled as B group elements, but in any case they're in the D block in the middle, light blue behind me, or medium blue I guess. Anyway, those ones are going to be when they do anything besides with their valence electrons, it's going to be because oxygen is involved. If oxygen is not involved, probably they will just have their valence electrons react. Okay, that was the eraser. All right, so I can take this this circle here, and I can just put a default circle there. I can move it around, and I can duplicate it. And duplicate it again. I don't need to go back over and over to the same source. And let's say I want this one to be in the middle, and I'm going to call this one nitrogen. So I'm going to get a little text box here, and I'm going to put a capital N here. It's pretty simple. Okay. Then I'm going to put a bunch of these as hydrogens. I'm going to shrink them just a little bit, and then I'm going to say, I wish I had duplicated these rather than the other one. So I'll duplicate that, and then I will select these and delete them really easily. And then I will put a little text box here. Now, if I put a little h, or rather capital H here, this does not duplicate if I just duplicate it. Okay, it didn't become one object. Okay, I can send it to the back, but it didn't become a new joined object. So it doesn't have quite as many powers as paint does, or a lot of other things. So you do want to position these before you put the H's on there. Now, you'll notice that I'm arranging these temporarily. It looks like, oops, no, I want to move the H, I want to move the circle, there we go. That I'm trying to center these on the same lines as, as if it was two-dimensional. I could make them three-dimensional, but for now, as an example, I'm just going to make it two-dimensional, and then I'm going to want to have some bonds between there. Okay. Now I can make the electrons as circles again, but then I get a bunch of circles. So this is where I'm going to go up here, and I'm going to make the electrons blue. Okay. And I'm going to use the marker just to be a little bit bigger. And how many electrons do I need to have between the nitrogen and a hydrogen? While you think about that, I'm going to put the H's here. How many electrons do I need?
2.
2. Right. Thanks, Naya. Yeah, I'm going to need 2 because hydrogen can't handle any more than that. So let's make sure I have this again. I'm going to have 2 electrons. Now, I just draw them here like Lewis would have me do it. But we know that they're not just hovering there, stuck between these two. We know that they have made a new sigma bond around nitrogen and hydrogen. But for the sake of simplicity, we do that. We're going to do this over here with this hydrogen we do it over here with this hydrogen. The exact position is not so important, okay? You can use red, you can use black, it doesn't matter. I'm going to know that if you do squiggles, you're dealing with electrons. And then nitrogen does need a full octet, so it has its lone pair up here that's not attached to anything. All right, and then someone who hasn't answered yet this morning, what molecule do I have here? Hello? What's the name of this molecule here?
I have no idea.
Okay, thank you, Austin. Anybody else have no idea?
Does it start with an A?
It does, yes.
Is it, I want to say, has two M's, right?
Yep. You're halfway there. It is ammonia.
Yeah.
Sorry, I cut you off there. Yep, ammonia. And it's named for an Egyptian god, Ammon. And they had literally, they had a salt mine right next to a temple. And so, they dedicated the salt to the god that the temple is for. And ever since then, we've been calling it ammonia because the salt was ammonium chloride. So maybe you didn't need to know all that, but that's where that word comes from. It's kind of a random word because of Egyptian religion thousands of years ago. So anyway, ammonia. Now, ammonia is a lot like water in the sense that it's one nonmetal surrounded by as many hydrogens as it can have and still be neutral. And it's got a lone pair, okay? So one central nonmetal, it's full of hydrogens, and it has a lone pair. So it's a bit like water. Because it only has one lone pair, though, its hydrogen bonding is weaker. It does have hydrogen bonding, but it's weaker than water's, and so at room temperature, ammonia is not liquid. But with a bit of pressure, it liquefies fairly well. And so farmers will take liquid ammonia in a tank on the back of their trucks out into the field and spray it on the plants because it is a fertilizer. It's the thing that plants just love with that, because on land, the limiting nutrient is nitrogen, and this ammonia is the way to get nitrogen in there. If you put out nitrates or other nitrogen containing compounds on there, the plants won't really know what to do with it. But you spray ammonia on there, which is easy to do because it's liquid in the back of the tank. It comes out as a gas, spreads around. They just literally breathe it up, gets in their system. They grow so much better. There's plenty of carbon dioxide food for them. There's plenty of water for them, unless you're in the desert. What they're missing is, and the other trace things that they need, like magnesium. They've got all that. Plants and solid ground have plenty of that stuff. What they're lacking is nitrogen they can use. The nitrogen that floats around in the air, the element nitrogen, does almost nothing for them. It's basically like a noble gas. So it has to be changed and put into ammonia form, and then the plants love it. And because even though it's so light, because of hydrogen bonding, it can be liquefied fairly easily. And then, it's quite useful. Now, again, the history of this is tainted. You know, the process to cheaply make ammonia was invented by a guy who wanted to use this as a poison gas in war. And he did use it as a poison gas in war. He and his country did. But nevertheless, the technology behind the process to make it has allowed for farmland to really spread around the world. And I've said it before and I'll say it again. We could not have 7 or 8 billion people alive on Earth today if we didn't have the farmland that was fertilized by ammonia. Again, that gets into a whole debate about whether there should be 7 billion people on the Earth that I do not want to have because I don't want to be picking and choosing. But in any case, you should know as you're almost adults that debate is out there. And there are a lot of views on that. So please understand that this molecule you're looking at is a very powerful molecule. Without it, we could maybe have 3 billion people. And there would be many more people starving to death if we didn't have this than we have now. Sadly, we do have people in the world today starving to death. But the number is way lower than it ever used to be, even though we have way more people. It's not just a percentage that's gone down. The absolute number of people in famine is minuscule compared to what it used to be. And you can look at the historical numbers for that too. So yay, ammonia. Sorry that a lot of people were killed because it was a weapon at first. Chemistry is that topic that you know, lends itself towards weaponry very, very easily. So it's not the point of this class, but okay. So I just wanted to show you how on Jamboard you as well can show me your molecule making skills. I haven't been having you do this much. I've been kind of feeding you a lot of lecture, but now I'm going to be turning it over to you for a while to be working on your own diagrams. And so what I'm going to do is I've given this the name ammonia. It has a common name, but I'm also going to write the chemical symbol here. Now, you'll notice that it's NH, but I need to have 3 of them here, right? So if I go up to here, I can go down to caption. Oops, Control Z. All right. I don't want to do that. Let's see here. Well, it looks like I won't be able to. I thought I was going to be able to have this easier than this. But if I go out and then I go to text box again, and this time as a small text box, I can put in a subscript. You see here, NH3. Something you can't do too well on, what do you call it, on a Google form. Okay, ammonia NH3. Now, the nice thing about Jamboard is once you have shared, and I don't want you to go back and use the old one. It's a new semester, make a new one. You can have up to 20 frames. If you want to think of them as slides, you can, that's fine. 20 frames. So you do not need to make and share a lot of these. But when I put an assignment onto Google Classroom, please do not turn in the Jamboard. Okay, just make it and share it. The directions will be on Google Classroom. That's where you're, just pretend I gave you a sheet of paper with directions, okay? You keep the sheet of paper. Don't give me back the sheet of paper with the directions. You will be on your computer and you will be drawing these and just keep it shared, and then you'll be adding more and more frames as we go along. Anybody have a question about what I've said so far?
So basically, we're just going to do what you just did on the Jamboard.
Yeah, basically you're going to do what I just did on the Jamboard. I'm not going to require you to have a particular color for electrons. And if you wanted to use the little circles for electrons, you may. There are certain boundaries where I want you to have separate shapes for separate elements, and I also don't want you know, weird shaped things like triangles for elements. But I also don't want to restrict your creativity too much either. If you want to hand draw something, you know, if you want to use different particular colors, I can't think of all the ways that you can do this. You can think of a lot of ways, and if on the off chance you do something that I don't understand, you're going to have a chance to go back and edit it, because again, you haven't turned it in. Because once you turn it in, you can't edit it. Okay, so make sure you do not turn it in. You just share it, and you're free, of course, also to share with other people if you want them to be able to see it. You know, make it so that you can do that. But what I don't want is for people to make it and then just, you know, give it to their friend as a copy. I know that that's very possible to do on computers and that sort of thing. And you know, in the adult world, you're not required to do extra work, but I want to make sure that you can individually do this sort of thing. So I'm asking you, please do not just, you know, help out a friend by making one and then giving it to them. So yeah, basically doing that. It doesn't have to be ammonia, of course, but what I'm going to do is I'm going to put some directions onto Google Classroom later today. Today is Thursday. You'll have some time to start working on it, but you'll also have some time to work on it tomorrow, Friday, during class, and actually be drawing it. So at least by the time tomorrow's class is over, then each of you will have had a Jamboard made, and by, you know, and it'll be named according to certain directions so that I can find it very easily, and then you'll have 2 or 3 molecules drawn, hopefully by the end of the weekend. Okay, by the time Monday morning comes around, and you should be able to do this. Now, let me make another frame here. Okay, I know we're about out of time. Okay, and I'll go ahead and use the dots background again. You're not restricted to the using the dots background. I just am doing that. And so here again is nitrogen. Okay, I'm going to put that as N. Okay. And then I'm going to make another few circles. First, I'm going to shrink it, and then I'm going to duplicate it. Okay. And this time, I'm going to make 4. I'm going to arrange these. Looks like we lost somebody. Okay. And I'm going to do this basically in a tetrahedral shape. And you'll see here it's a bit bigger than 90 degrees. And that's where we have to stop. I'll show you this again tomorrow. But I'm going to put the directions on there later on. You do not have to begin today, but you can. And I'm going to go ahead and stop the recording now as well.